Chemistry research today is covering sustainability crises. For instance, research into alternative energy like solar and wind has led to the development of solar roadways. Electricity is not the only focus on sustainability, though. Research into synthetic materials is also making strides. Bioplastics, as they are called, are made using fibers and sugars found in plants to make the substance we have been dependent upon for a multitude of our daily functions. First thing to discuss is where did plastic come from? While plastic has been created as a byproduct of other industrial reactions involving acid, it was originally discarded as waste material until chemist Leo H. Baekeland found a use for the tarry products formed by phenol and formaldehyde. He created bakelite, a substance that could be molded into a certain shape at high pressure and temperature, and would not be softened or dissolved. This new use for synthetic materials sparked a large plastics industry. Chemists gradually learned the nature of these materials, such as ideas that they were polymers instead of colloids. One team, led by Wallace H. Carothers, discovered nylon, originally a sticky material with little structural integrity. Julian Hill, under Carothers' team, realized that when nylon was drawn away from its solution it formed a strong, silky string. Other widely used polymers are PVC, polyvinyl chloride, and polystyrene, commonly referred to in error as styrofoam. Here in the lower right, you can see polyethylene, the most common petroleum-based plastic used today. Well, next question is, what is so bad about the plastics we're using today? The most common plastic used today is polyethylene, I just said that, made of repeating C2H4 monomers. These molecules are found in crude oil, a non-renewable resource estimated to deplete within the next century at the rate of consumption of the world. The polymerization process of the oil produces pollutants like carbon dioxide and vast amounts, which contributes to climate change. Another problem with common petroleum-based plastics is they are non-biodegradable. Whereas most natural materials take up to 3 months to decompose underground, plastic bottles take up to 450 years. This is why bioplastics are becoming popular. Dasani, under the Coca-Cola Company, recently began selling water from their copyrighted plant bottle, which contains 30% plant material. The two most common bioplastics used in industry are polylactide acid and polyhydroxyalkanoate, or PLA and PHA respectively. The process for polymerizing lactic acid involves taking multiple small chains, called oligomers, and binding them together. This is because each time a molecule of lactic acid is bonded, water is released, which prevents the longer chains from staying together. Over 150 different monomers of PHA are produced by bacteria naturally. Each monomer contributes to a different property to the end product. So, are bioplastics good for the environment? While production of these materials are a lot less damaging to the ecosystem, consumers must take care to dispose of them properly. Bioplastics are compostable, meaning they'll deteriorate with heat, moisture, and microbes. Basically, leave them out in the Florida sun, and the plastics will be reduced to water and a negligible amount of CO2. The gas release concerns some scientists, but composting bioplastics is far more preferable to burying in a landfill. There they can decompose to methane gas, which is considerably more toxic than carbon dioxide. Scientists are already moving on to the next step in bioplastics industry by creating grass that will naturally produce the materials needed to polymerize bioplastics. And once they harvest that, they can use the grass for a natural fuel source, thereby eliminating waste. Now you can make your own bioplastic. Put your goggles on and gather the following materials: a tablespoon of cornstarch, 2 drops of corn oil, a Ziploc bag, 1 tablespoon of water, food coloring, and a microwave. Place the starch, oil, and water in the bag, seal it, and mix the ingredients by rubbing the bag with your fingers. Add a couple drops of food coloring to the bag and mix it again. Leave a tiny opening in the top of your Ziploc bag and then microwave it for 20 to 25 seconds. While the plastic is still warm, try to mold it into a ball. Dispose of your bioplastic by submerging it in water. Thanks for watching!